First, going to start with converting quadratics. Sarah's on choir and can't. I know. Actually, like a lot of people are on choir tour. Yeah, makes sense. But that's all right. She can watch the video after, right? Okay. So starting off, solving or converting quadratics. So we've got three different forms of quadratics. There's standard form, vertex form, and intercept form. Should know all of these and their general form of them. Some people don't yet. It's okay if you don't. It's not mandatory, but knowing them is definitely helpful. So standard is ax squared plus bx plus c. Vertex is a times x minus h squared plus k. And intercept is a times x minus p times x minus q. There's our three forms we learned. So first, we need to know how to convert between them. So first of all, to get to standard form, all you have to do is multiply everything out. You know what? I'm actually going to rearrange this like I did it in class, because it's going to get confusing if I do it different here. If I did in class, I did this rainbow here. So we can grab all that. It's standard there. Vertex maybe here. Intercept over here. Yeah, this will make it look a little more familiar for when we did it in class. Okay, there's our three forms. Get them spaced a little bit here. Are we taking the test on Thursday? No, we are not testing until next week. No. Don't fret. Thursday is new stuff. Monday is kind of new stuff. Wednesday is review, and test is on Friday. So we got a ways to go. This is just a review. Since this unit's so long, we're just reviewing this first section. That's what we did in class today. We reviewed this first section. We're just going over that now for the stream, and then next time we'll go over the new stuff that we do. No frets. All right. Okay, going from each form. So going from any form to standard. Standard is like the most basic, the most multiplied out, simplified version, I'd say. So to get from any form to that form, you just multiply. So either way, no matter what you start with, if you ever need to get to standard, you just multiply everything out, distribute, etc. Nantare, are you Natasha? Is that who you are? Who are you? And why have you been missing class? Shame on you. Nope. Hey. Oh. Sorry, man. Sorry I've been sick. I hope you watched the other one. If you were here the other night when we did the review of solving vertex form, but we'll do one of those problems tonight too. So you'll see kind of everything you missed, hopefully. All right, so that's how we go to standard form from both of those. Now to go from standard to intercept. Intercept is AKA factored form. So to go to intercept form, we just factor. And then to go from standard to vertex form, we do what we call complete the square. Complete the square to go there. So we're going to do one of each of those real fast. So first off, let's convert a vertex to standard. Let's go 2x plus 2 squared minus 5. If I wanted to convert that to standard, all I have to do is multiply it out. So I'm right here, convert to standard. This is vertex form. So to convert to standard, we just multiply everything out. So x plus 2 squared is x plus 2 times x plus 2. So it's 2 times that minus 5. You just distribute these parentheses. You could distribute the 2 into one of the parentheses first, but in my opinion, it's easier to do the parentheses first. So that leaves you with x squared plus 2x plus 2x plus 4. That's being times by 2 and then subtracting 5. We can combine those two x's, make it 2x squared plus 4x plus 4 minus 5. Then we distribute the 2 all the way through the parentheses. So you get 2x squared plus 8x plus 8 minus 5. And now we can combine our 8 and negative 5. So we get, move it up a little bit, 2x squared plus 8x plus 3. There is your standard form. Easy as that, converting to standard. There's one example. That's from vertex to standard. Let's do it from intercept to standard. Let's say I start with negative 3, x plus 2, and x minus 5. Same thing here as we just did with vertex. The only difference is we don't have that negative 5 at the end, pretty much. So we're just going to distribute the parentheses first, the x and the 2 into the other parentheses. So x times x, x squared. X times negative 5 is negative 5x. 2 times x is 2x. 2 times negative 5 is negative 10. And there's that negative 3 in the front. Let's simplify the negative 5x and the 2x. So we get negative 3x squared minus 3x minus 10. Then we just have to distribute the negative 3 in. Negative 3x squared plus 9x plus 30. And there's your standard form. So that second one, that's from intercept or vertex, or sorry, intercept or factored form to standard form. That first one we did was from vertex form to standard form. So all they are though is multiply everything out and simplify, and then you're in standard. All right, converting from standard to factored form. Hello, Mr. Narwhal. Welcome, welcome. Let me get a problem real quick to do for that. Okay, our standard form is going to be, so that was our converting to standard. Now we're going convert to intercept. So we're going to start with 2x squared plus 8x minus 42. So converting this to intercept just means factor. This is going to be a quick example because we should be good at factoring. I'm going to start by taking a 2 out because it's the greatest common factor and will make my life easier. Okay, now we look for two numbers that multiply to make negative 21, a times c. Two numbers that add to make b, which is 4. These two numbers are going to be 7 and negative 3. Since my a value is 1, I can just shortcut to my answer here. X plus 7, x minus 3. We got from our 7 and negative 3 here. And then make sure we tack on our 2 that we took out at the beginning. For more advanced factoring, hopefully we're good on those. Hopefully we're good on the more advanced factoring. If not, that you just need to do practice. You just need to practice factoring. Go back to the homeworks. Go back to the note guide. Do the examples. Practice factoring. That's converting to intercept, just factoring. Okay, next one. Let's go up here. Or where else do we got room here? Use a spot right here. Last one is going to be converting to vertex. We do this by completing the square. Now this looks kind of similar to the area model factoring, so you just got to make sure you don't get confused between the two. All right, let's do, oops, wrong button. Let's do one 6x squared minus 24x plus 9. So I could take out a greatest common factor here. Chinese New Year, didn't do any math. That's a pretty good math day, Hayden. Kind of wish I had your math teacher. So to complete the square, we need to find a square that contains 6x squared and negative 24x in it. Because our vertex form equation, let's look at it real quick here. Our vertex form equation always has this x minus h square in it. All of our x's are in that square right here. The a is just a constant and the k is just a constant. So first goal, before we complete the square, I like to call it finding the square or building the square. We need to make a square that has all these x's in it. So 6x squared, it has to have that in there. It also has to have negative 24 x's. And if we want this to be a square, then these two lengths here, this length and this length must be the same. These whole sides, rather, need to be the same, which means I need to split those 24 x's up evenly. The negative 12 and negative 12. Okay, at this point, we know that our end answer here is going to have just an x minus h in it. It's not going to be a 5x. There's not going to be a number in front of that x. It's just x minus h, which means I can take an x out to the side here and then solve the rest of the sides from there. So if that's x, then this top one must be 6x to make 6x squared, which means this bottom side needs to be negative 2 to make negative 12x. And this side one here needs to be negative 12 to make negative 12x. And then our bottom right box will be negative 12 times negative 2, which makes 24. From this point, it's helpful to recognize that the 6x minus 12 is the same as 6 times x minus 2. So what we have here, this area isn't really a square, it's rather 6x minus 2 squares. It's 6 times x minus 2 times x minus 2, which is 6x minus 2 squared. So we built our squares that have all the x's. Now, this square here, these squares have a problem. Total, they have 24 units in them. But our problem only asks for 9. So we've got to make a correction here. We've got to add or subtract something here to get to 9 from the 24 that our squares gave us. So here we are going to minus 15 to get to that 9. And we put that just on the end of our 6x minus 2 squared. This is your vertex form. Okay, so that's it for converting. Converting to standard. Multiply everything out. Just multiply, multiply, multiply. Multiply correctly, I would say, is the most important thing there. To get to intercept or factored form, just factor. And to get from standard into vertex, complete the square. Find the square, build the square, then complete the square. All right, now moving on to solving. We've learned 2 different ways to solve so far. We will learn the third next time. The 2 we have learned to solve so far are solving from intercept or factored form and solving from vertex form. So let's draw out an equation here in intercept form. The key to solving in intercept form is this idea that if I have any number of things being multiplied and they're equal to 0, then if any of these things are equal to 0, the statement will be true. This is called the zero product property. Because if one of my terms, so let's say this 2 was 0, it's not, but if it was, then no matter what else I multiply by it, I'm going to get 0 out. Same with this x minus 2. If this x minus 2 is 0, then no matter what I'm multiplying by, I will get 0 out. Because 0 times anything is 0. And if this x plus 5 is 0, then whatever I multiply it by, it's going to give me 0. That's called the zero product property. We're going to be using that to solve these. So to solve from intercept form, it always has to be equal to 0. It has to be equal to 0, because otherwise the zero product property doesn't work. So this is equal to 0 already. So I just have to say what makes this x minus 2, what x value makes that x minus 2 equal to 0? Well, it's 2, because 2 minus 2 is 0. For the second one, what makes this part equal to 0? Well, it's negative 5, because negative 5 plus 5 equals 0. So the two solutions to this are x equals negative 2 and x equals negative 5. For a little bit harder one, let's do ones that don't just have x's in them. If you factored an equation and got something like this, well, let's not do a negative. Let's do 11. If you factored a standard form equation, got something like this, you're going to have to do a little bit more work. You've got two options here. You can either, one, get these x's, this 2x to be just x by factoring out a 2 from both of these. So you'd get a 2 out front, and each of these would be divided by 2. And then it would look like this. You'd have x, 2's cancel, so you'd have x plus 5 over 2. And now it's easy to see what makes that 0. It's just negative 5 over 2. The other option is, if that's confusing, is just take 2x plus 5 and set it equal to 0 and solve for x. That will tell you what x value is going to make this equation, this piece of the equation, equal to 0. So you'd subtract the 5 over 2x equals negative 5, and then you divide by 2. Either way, you would get x equals negative 5 over 2 for that one solution on the left. On the one on the right, do the same thing. I think it's easier to just factor them both by 6. So that would convert or factor out the 6, so you'd get x minus 11 over 6 for that term once the 6 was out, which shows you that x must be 11 over 6 to make it equal to 0. So your two solutions are x equals negative 5 over 2 and x equals 11 over 6. That is solving in intercept form. The only other work you'd have to do is if your problem started in standard form and it said solve by factoring, you'd have to factor first to get to these equations right here. And before you'd factor, you'd want to make sure it was already equal to 0. Because once we get into this factored form, we can't just subtract or get rid of a number that's on the side. We'd have to put it back into standard and move that number over first to get it equal to 0, and then factor. Okay, so that is solving by factoring, or solving intercept form. Next one is solving with square roots. Solving with square roots, aka solving from vertex form. So if we have a vertex form equation, like this, we can solve this using square roots. This one is simpler because there's no trick to it. All you have to do is get your x alone, and that will tell you your answers. Now to get x alone, we're first going to we're going to at some point have to get rid of this square. To get rid of that square, we want to get the squared piece, so this entire thing, alone so we can square root it. And that will cancel out the square. The first step is thinking, how do I get this entire squared piece, x minus 4 squared, alone? To do that, we're going to minus 7 from both sides. So then we're left with 2x minus 4 squared equals negative 5. Now we need to get rid of this 2 here, so we divide both sides by 2. So then we get x minus 4 squared equals negative 5 over 2. Now that our squared piece is alone, we can square root both sides to cancel the square. We square root the left and square root the right. The square and the square root cancel, but over here on the right, we need to make sure we add this plus or minus symbol. And if you didn't see why, look at my last video. Watch my last video, I explain why we have to include that plus or minus symbol. Simple explanation is because when we're looking for a solution that when squared equals an answer, like if I want to know what number squared equals 9, there's 2 answers to that. It's negative 3 and positive 3. Each of those are solutions. So to represent that, we do plus or minus 3. Okay, but moving on with this problem. So we square rooted both sides, which leaves us on the left with x minus 4 equals plus or minus the square root of negative 5 over 2. We've got 2 things left to do. We still need to get our x alone, and we need to simplify this square root. Welcome, Bobby. Welcome. Late, but welcome. So we could do either one first. I'm going to choose to simplify the square root of negative 5/2 first. So to simplify this, the square root of negative 5 over 2, anytime you have the square root of a negative, the first step to simplify is change it to a positive and put an I in the front to represent an imaginary number. From that point, we just say, can I simplify the square root of 5/2? So if you put this in a calculator, you may get a more simplified form. But that being said, you don't necessarily have to simplify this, especially not in our class. You could leave it right there. Bobby with the Twitch Prime. Thank you so much, Bobby. You found your password. Appreciate it. So you probably could have this more simplified by splitting it into 5 over 2 and then timesing the top and bottom by root 2, which would give you root 10 over 2. But keeping it as root 5 over 2 is fine for this class. So our square root of negative 5 over 2 just became I square root of 5 over 2. So we're going to replace that. So we still have x minus 4 over here equals, plus or minus is still there. That's just the sign of this thing. And then I square root 5 over 2. Last step is to get our x alone. To get our x alone, we just need to add 4 to both sides, which can be written like this. X equals plus or minus I root 5 over 2 plus 4. And the last step here is a little picky, but whenever we write numbers that have a plus or minus in it, we typically write this real number first. We're just going to switch the order here of these two numbers. Since it's addition or subtraction, we can just switch the order. So we say x equals 4 plus or minus I root 5 over 2. And that's your answer. That is 2 answers, actually, but we write it like that because it's simpler. But it really means x is 4 plus I root 5 over 2. And the other answer is 4 minus I root 5 over 2.